Thank you, everyone, for joining us. I'm Raj Talluri, President and CEO of Inovix. We are very excited today to hold our very first AMA, short for Ask Me Anything, live stream. As I mentioned when I joined the company, it's my goal to be transparent to all our stakeholders and take you along on the journey, and that's what today is about. Now, before we get started, I do want to remind everyone that our live stream is being recorded, and the replay will be available on our YouTube page afterwards. Now, in addition, given we are a public company, and it's important to highlight that we may make forward-looking statements today that are subject to risks and uncertainties and reflect what we know as of today. This is May 6, 2024. Please, as always, read our risks and disclaimers in our SEC filings. Okay, so in terms of format, we've received about 100 questions in advance, and we're expecting easily as many in the comments during the call. Now, we may not be able to get to all of them. I'll try to answer as many as I can. Now, that having said, I have a moderator here with me who will read the first question, read all the questions that are pre-submitted, and I will answer them first. And then as we have time, I'll go into the questions in the comments. Now, before we go to the moderator, I do want to address the news of some of the cuts that we've made that have been reported. Now, consistent with our earnings call, we've reduced our burn by $35 million, or 1/3 of fixed costs. Now, the cuts we announced today, a vast majority of them are actually hourly factory workers that have been working in Fremont, mainly making EX-1M cells, so we could get our technology moving forward and sample early to customers. Now, our factory in Malaysia, as I mentioned in the call, has come up really nicely. And I was there a couple of months ago, super excited by that. And in 100 days, the team there was able to build a phenomenal factory. And our agility line machines, almost all of them are now there after FAT being complete. And the line's getting installed, and SAT should be done soon, which means we can get samples from there. So that's the reason why we felt we did not have to have a high-cost, manual manufacturing line here with lots of hourly workers working on making batteries. Now, this expands our runway well into 2026 and gets us to profitability sooner. Okay, with that, let's kick off the first question. Moderator?
Thanks, Raj. So the first question is, one thing that wasn't discussed on the earnings call was military or EV. Has there been any progress on that front?
Yeah, great question. So on the military stuff, as I mentioned, we have this Brak Flow technology, which makes our batteries extremely safe. And we've been working with the U.S. Army, where they would like to have these safe, high energy density batteries to power the vests that every soldier would wear and keep them safe and also going for a long time. We have shipped quite a few batteries to them, and that contract is going well, and we will continue to make more batteries as their testing continues, and we expect to send them some more later on. I also want to highlight that the business we acquired in Korea has a very strong, stable business of making batteries for the Korean military, and that's an opportunity for us to actually expand those batteries into other opportunities in other militaries. Now, on EVs, we are very excited by this business. We didn't get to talk about it in the earnings call, but back in February, we signed our first development agreement with the Tier 1 auto OEM, and since then, we made a lot of progress. And what's driving the interest here is twofold. One, the architecture we have has the ability to enable the battery to charge really fast and also make the heat dissipate really quickly. Now, one of the issues in cars, as you know, is when you charge fast, the battery heats up. That limits how quickly they can be charged. And we find that our architecture has an order of magnitude better heat dissipation because of how we orient our electrodes. This enables fast charging and the overall health and stability of the battery. The second advantage we had is that our architecture, the way we make the batteries, does a really nice job of handling materials that have the property to swell when charged. Now, many materials swell when they're charged, and particularly as you increase energy density like silicon. But our architecture is agnostic of which material you put in there. We're able to control the swelling of any material that swells because of this. and made a lot of progress with this OEM. Things are going well, and we expect to get them some batteries by end of this year. And we're also working on other EV OEMs, also making good progress there. Okay.
Okay. Next question. Raj, we received many variations of this question. When can we expect to hear a customer announced?
Yeah, so this is a really good question, and I know a lot of people ask me this question, but I want to give you some context. Right now, we are working with majority, if not all, the smartphone OEMs, and that's been the focus of the company because I felt that's an area where our energy density increase we're able to provides maximum benefit, with the AI applications that are coming onto the phone, and we got very good customer feedback on that. Now you got to remember, these customers, already have existing suppliers that they're using, and we're a new company that's coming in with a new battery to them. They like what we provide. They want to work with them, but they can't really go out and tell everybody, hey, I'm using an Enovix battery way ahead of time because they got the existing supply base to worry about. This is something, and also, this is such a differentiated battery that the OEMs like to keep it, the fact that they're working with us a little bit more guarded, and I totally understand that. That having been said, my experience is that typically a couple of months before production is when the OEMs will allow us to mention their name, and I'm working on that. Meanwhile, we will continue to do announcement like we did before, which is we basically said, we announced the fact that we work with the OEM and we got the agreement reached and so on. We also did that with auto. We did that with the smartphones now. And as we continue to make progress, we will continue to do that. Now in auto, it's even trickier because some of these auto companies have got some other battery suppliers that be given the long lead time. They work with them for a while now. So please be patient with us. A lot of good traction. I'm really excited by the work we are doing. Our architecture enables us to produce much better energy density, and the customers are super excited by that. But but the ability to announce the names will come as we get closer to production.
Okay, next question. Raj, we have received a few variations of this question as well, which is that there are many smartphones in the market with fast charge. In some cases, up to 5C or 6C with long cycle life. How will our batteries be competitive against those?
Yeah, so really good question. I first want to talk a little bit about all the various care-abouts our customers have when choosing a battery. One of them is fast charge. How quickly can you charge, get to some amount of charge capacity on the phone, and move on? The C rate, 5C, 6C, 4C talks about, how fast does the battery get to, 50% charge, for example, or so on. Now, in the battery, there are competing requirements, fast charge, energy density, cycle life, how long can it go, safety. These are all things that actually compete against each other a little bit. For example, you can make the battery go really fast in terms of charging, but you give up a lot of energy density because what happens is when you want to make the battery charge really fast, what you need to do is you need to thin the electrodes, for example, so that the lithium is able to quickly come out and go into the cathodes and anodes. But when you thin them, the amount of energy density you get is lower because now you don't have as much active material there. So it's a trade-off between fast charge and cycle life and energy density and safety. So we spend a lot of time addressing all of them. And it's kind of like a spider diagram, if you will. And each OEM is a little bit different. In fact, some of the phones in the market now that do 5C, we actually got those phones and we did some analysis. The energy density is dropped off way low when you talk about that. And also, even when people say it's 5C, many cases it charges really quickly. Like, for example, you're at a zero charge, 0%. It'll go up to 20% really quickly, but then it slows down. And then to get 100% charge may take longer. So it's, every OEM has a slightly different view on how the batteries should charge fast. And our technology has the ability to adjust to all of those. And we're making the right trade-offs along with our customers on that.
Okay, let's go to the next question. Raj, we received a number of questions about EX2M and the roadmap. Specifically, what technical hurdles are there in increasing the energy density on EX2M, and what changes will you need to make to achieve the increased density? There's a second part to this too, and that is that what are your expectations for cycles and increased density for EX3M and beyond? What is the maximum increase in energy density we could see from silicon batteries in the future?
Awesome. Great question, and thank you for that. So as a company, we are focused on getting higher and higher and more and more energy density into the batteries that we make. And the way we do that is by this unique architecture we have, where we were able to harness the power of silicon to be able to hold a lot more lithium than graphite. But when you do that, as you know, the battery swells up, so we had to control the swelling. And we control the swelling by this unique mechanical architecture that we have, where we slice the anodes and cathodes into really thin strips and hold them together. So we've done that with the EX1M. On EX2M, we have a lot of other things that we haven't fully optimized. For example, we can have much higher density of LCO cathode, for example, powder on top of the cathodes. We can increase that. And the other thing is we can decrease the amount of inactive material, such as the separators and the constraints. There are new anodes that have come about since we have started that actually can hold a lot more lithium and go longer. There is ways to make the column collector thinner. So there's lots of other interesting things that we have in the works in our R&D labs that we can do on top of what we're doing in EX1M. That enables us to increase the energy density, but at the same time, keep the gains of fast charge, of cycle life that we have achieved with EX1M. So it's really, really exciting. And all of this is made possible because we are able to use silicon, 100% active silicon instead of graphite, which can hold much, much more lithium than graphite. With EX3M, similar concepts. We will continue to optimize the amount of cathode. We will continue to find different silicon anode materials. And also the electrolyte. The electrolyte is actually one of the things that a lot of people don't quite talk about. It's a very interesting thing because the electrolyte has to behave one way when it's connected to the cathode, has to behave differently when it touches the anode. So we have a lot of different electrolyte formulations in the company that also help us, kind of get both energy density and fast charge. So those are just some high-level things that I mentioned. I know we have a team in India now. The India team has come up nicely where we're doing a lot of R&D, where we're able to predict what kind of changes give us what kind of advantages in terms of new material, in terms of new electrolytes, in terms of new cathodes. We can quickly figure that out and then use it in our Fremont R&D to make cells and manufacture them very quickly in Malaysia.
Okay, let's go to the next question. Raj, we're going to pull a few questions together here about the composition of the battery.
Yeah.
They are, one, for the constraint system, some keep stating it adds weight and size. I believe it is negligible. Can you clear up confusion there? And then I'll tack on the other part of this question is similarly, someone asked, could you share battery weight efficiency and how it compares with existing smartphone batteries? And last, how many electrodes are stacked in a mobile phone cell? Is there a limit?
Yeah, so all good questions. Firstly, the constraint system that we use to hold the battery, hold the electrodes, we use stainless steel. It's really, really thin, what we use, and stainless steel is a very strong material that can actually hold this, electrodes very well. Because we slice the electrodes thin this way, they don't apply as much force, on the sides. If we actually just put the electrodes stacked like that, it put a lot more force. But because we make them like this, a lot less. So actually what I want to do is I want to show you guys a cell. This is actually the battery. This is the EX1M cell. You can see here, we took it out of the pouch, so all you see is the cell. And you can see here, the electrodes are kind of stacked like this, and the constraints and put on top of that and holds it like that. So now you can see when the silicon tries to grow, it applies the pressure upwards so we can hold it down and not this way. If you actually want to see the constraint is actually this. You can see how thin it is. It's like paper thin, this is just a stainless steel constraint. And it has these slats, which, allows you put the constraint on like that. You can see here on top. So you can see and there it is, and that's how thin it is. So it's really negligible in terms of the weight it adds. It's like paper thin kind of thing you can see here, right? So that's really not been much of a concern. In some cases, when you're, maybe make a drone or something that's flying, maybe, the weight, maybe every little bit of weight may be an issue. But in the customers we've talked to in smartphones and consumer electronics, this has not really been an issue at all. And in terms of stacking, the number of electrodes we stack, depends really on the size of the battery. The bigger the battery, the more we stack, and also depends upon how much milliamp hours we want. The more milliamp hours we want, the more higher we stack and the wider we make it. So the constraint, the shape and the stack really depends upon what's the size, what's the capacity of the battery, if you will. That's why when we make the electrodes thinner, you can stack more of them, but there comes the trade-off of how much energy can be in each electrode.
All right, let's go to the next question. The next question is regarding the size of the smartphone OEM TAM opportunity. Is the $12 billion opportunity based on current prices, OEMs pay for batteries, or is the $12 billion opportunity based on the increased ASP Enovix expects to charge?
Yeah, so the TAM of the battery, the TAM of the battery is really a blend, where we assume that the battery has a different price point based on which tier of the market. For example, this is something I saw in smartphones for a long time. The premium tier smartphone could pay like, $60 to $70 for a processor. The entry tier could pay, 10 to 15 or even lower for a processor. So the entire bill of materials varies based on low to high, which tier of the phone you are in. So does the battery, but the battery doesn't vary that much because you still need a sizable battery to run these things. So we used a blend. But I can tell you this much, though. Clearly, the battery capacities are going up. I mean, today, we see now 5.5 hours, even 6 hours. This is just my prediction. Raj Talluri's prediction is that we're probably well on our way to a 7 amp hour battery or even higher. Now, why is that? That's because the Gen AI applications. I mean, I showed some data where just ChatGPT burns more of the battery life than YouTube. And these are just coming. And I saw the same thing in my experience with smartphones. The memory kept moving up. The processor performance kept moving up. So as you get more and more of these applications demanding more and more battery life, the size of the battery goes up. I mean, the capacity of the battery goes up. But, as I mentioned, the size of the battery cannot go up because the phone size is kind of fixed, right? I mean, you can't make much bigger phones. That's where we have an advantage because we can take a battery like this and put it in here, which is much smaller, but still get to quite a bit of energy density. So because we are able to provide energy density in a smaller form factor, we can go to 6 amp hours, 7 amp hours, but still not make the form factor of the battery go up too much. And there is a lot of value to that, and that's where I believe that we can get a much higher ASP premium.
All right, let's go to the next question. It's a question about the risks you see. What is the risk that AI or tech advancement does not lead to a pressing need for a greater battery capacity? And what is the risk someone produces a better battery than us? Last, what is your overall perception of the risks the market tends to highlight and whether they are real or overblown?
Yeah, on the risk of AI and tech advancement materializing, I'd say in my experience over the last 30 years, I've seen the opposite trend. I mean, processor performance, processor demands and battery life, memory demands and battery life, display demands and battery life, camera demands and battery life has only kept moving, growing more, not less. That is with just the existing applications we know. The new applications, are just starting. I think they'll demand even more. If anything, I feel like we're probably undercalling, amount of battery capacity that needed to run these. I don't know if you guys use AR, VR headsets. I used the Vision Pro over the weekend. I mean, you watch one movie in 2 hours, the battery life is pretty much done. But the experience is phenomenal, from the eye tracking and so on. That's what is going to happen to phones. I think you'll get better and better applications. You'll get hooked onto them. You'll want them, but the battery life is not going to keep up. And also, if you see, the work that Qualcomm's are making, NVIDIA's, Micron's, they're not slowing down. I mean, they spend a lot of money and a lot of R&D in making better processors, better memories that only need more power. So I'm not too concerned about that. On the risk of someone making a new better battery, look, I'm always paranoid. I come from semiconductor business. The paranoid survive mindset. But I do feel like we have an inherent advantage that no one has really figured out how to use 100% silicon active anode, and our architecture is the only one that I know of that actually does that. So we have a built-in sustainable advantage. And I do believe that the materials will get better. Anodes will get better. Cathodes will get better. Our ability to understand the different interactions between cathodes and anodes and electrolytes will get better. But I believe that our architecture helps us take advantage of all of that and make even better battery. I've only seen people use between, I'd say 5 to 8%, something like that, of silicon in a battery before it just swells. So I feel like architecturally we have an advantage that I'm not too worried about that risk. I think there's one other question on market highlights. Yeah, I feel like there's a lot of people talk about, can we really make a battery? Can we mass produce it? Can we, do this sustainably? Yeah, there are risks that people talk about, but I'm pretty confident. For a long time, people said, "Hey, can these guys manufacture at scale? Will the yields be right?" And you look at our FAT results, and we are pretty happy with what we've done in about a year. So I think this is not the manufacturing of this battery. A lot of people are not sure if we can, and they're skeptical. But I feel pretty good because I've seen the machines, I've seen what they can do. We have a fantastic team, and we are solving these problems one by one. I think that is something that people talk about, but time will tell as we produce more batteries.
Okay, let's see here. So we had a few questions about Brak Flow. What is the plan for Brak Flow with fast charge? To my understanding, the Brak Flow solution is a set of resistors built into the bus bar. Has this been solved for EX2M, EX3M?
Yeah, so Brak Flow, great piece of technology, which is basically a technology where this company invented, where it makes the battery a lot safer when there's like a short in the battery by providing an alternate current path through a series of resistors connected to the electrodes, so that the current goes, doesn't go all, straight into where the short is. And it is a technology that we've put into the cells. We're giving to the Army that they're qualifying now. They're very happy with the results. However, there is one limitation we need to solve, and our teams are working on it. It's because we add these resistors, the fast charge becomes a bit of a challenge because now you added more resistance in the path of the charging. But we have some other ideas. The R&D team has got some really clever ideas of how to solve both at the same time. We're calling it Brak Flow 2.0, which will allow us to do both fast charge and also get that safety together. And as we get more about it, as we make more progress, I'll be happy to communicate on that.
All right. Next question. Can you share with us what you learned during the FAT process? Obviously, you needed to make some equipment adjustments. What did those entail? And would you anticipate any adjustments to the equipment for the line 2 based on what you've learned?
Yes. So, FAT, the factory acceptance test, from a manufacturing perspective, you really have to take this super seriously, which means you need to have a whole list of checks you need to do in terms of yields, in terms of performance, in terms of accuracy, in terms of CPKs, which is related to the how the machine works, in terms of the distribution of the output that comes out, in terms of the throughput, in terms of repairability, and so on. We put a very, very rigorous FAT plan in place when Ajay came over and I came over, and we have stuck to our guns that only when all those checks are done will we accept the machine from the vendor. It's a very, very, I should say, tough, rigorous, high standards that we set up because we need to manufacture them in the millions. Honestly, that has caused a little bit of delay, but not a lot. And Ajay and I felt that was okay because we did not want to accept machines that are not perfectly passing our FAT. It took a little longer in Zone 3. This is where we basically put the constraint, and then we put the pouch, and then we pre-lithiate, and so on. What our vendors, or the people who make the machines, did wasn't quite up to our spec. It worked, but we really didn't meet the yield and the throughput and stuff that we wanted. So we said, hey, you guys need to come back with a spec that meets it. And it took a little more time. But we held our lines, and now it's done. Now it's done, and it's done right. And I believe in doing it once and doing it right and not repeatedly messing with it. So now it's good. Now, what are the next steps? The next steps for us is to reduce the cost. Our cost of manufacturing. The first battery line that we made, like $100 million is what we said. Again, I think since what we learned along the process of making these machines and our FAT process is that there are ideas to cost reduce this even more. We don't have to do it the way we did it in the first line. So that's why I feel like the next lines we order will be much lower cost than this. And once we execute it, and as I mentioned in the earnings call, our line economics look great when we execute them. And this is very compelling and with almost a 1-year payback on these machines. So we learned a lot during the FAT process. Again, like I said, we learned how to do it right the first time, set the bar high. But at the same time, as we watched that being done, we saw, you know what? We could cost reduce this part. We could cost reduce this part. We could make this part more efficient. So those are things that we learned as we were building this. And you'll see us roll those into our next lines.
Okay. Let's see here. Next question. Raj, we had a number of questions about the quantity of samples going out and whether we will charge for those samples. Can you address that?
Yeah, absolutely. I mean, so right now, as I mentioned, we're making just a few hundreds of samples from our Fremont line, and with what we announced today, that'll quickly come down in the next couple of months. But at the same time, our agility line will be up in Malaysia, so we'll have a ability to make a 100 UPH line, whereas we were making barely, 100 cells a day here. So it's like a huge 24x faster in Malaysia. So it really speeds up our R&D because they run experiments and a lot more. Speeds up our ability to give samples to the customers. Typically, whether we charge customers for samples or not depends on two things. One depends on how many samples, and also depends upon how strategic the customer is. I've seen it done both ways. But when people go from hundreds of thousands to 10,000, 20,000 kind of samples, we absolutely charge for that. So I think that'll be to the later part of this year.
All right. This is a series of questions. Raj, do you want to take them one at a time?
Okay, sure.
Yeah. All right. So the first one is the European Union. Excuse me. The European Union will require all phones, handheld consoles, and similar devices to have user-replaceable batteries by 2027. How will this affect the Inovix's strategy, where cell users will want to replace their batteries without upgrading their phones?
I think if that happens, that's a great tailwind for Inovix, because right now the issue is the qualification times of getting a battery designed in and ramped into a phone takes a long time, because you have to decide on the shape of the battery, how the battery fits, and for each phone it's a little different, and we got to qualify it along with everything else in the phone and get it all working, and it takes some time. But if the batteries are replaceable, the beauty of it is we can make a higher energy density. For example, let's say we have a battery like this, which is a EX1M battery, and it goes into a phone. Now, we can replace the material inside that, which means the anodes, the cathodes, the electrolytes, produce much higher energy density in the exact same footprint. So now customers will have an option of buying a phone and later on buying another battery which fits in the exact same slot, but has much higher battery life, much higher energy density, much higher fast charge capability, and so on. So it's a really good thing, when that happens. I mean, clearly, I think there's things to be worked out about, is it waterproof and all that kind of stuff. But I think it's a good thing.
That's great. So next question is, if customers are sampling off the Agility line, is there any further testing that has to be done with the batteries produced from the high volume line once it's up and running? Yeah.
Really good question. The kernels of the machines, like for example the laser, the one that stacks, the one that puts the constraint on, they're all common between the Agility line and the high volume line. The difference really is that the high volume line runs much faster, and it has conveyances. That means you can go from the stacker, from the one that cuts the dicing to the stacker just automatically. It just moves. In the agility line, we don't have all those conveyances built in, so it's a little cheaper machine. And it also has just different sizes. So from a customer perspective, it shouldn't be that much different. My experience is anytime you move a line and change a machines, customers would like to test a little bit more. But my expectation is that'll be much lesser.
So another submitted question, comment and question says, we can't expect a major EV OEM to allow them to be named for many reasons. But can't we come out and say top 5 car OEM in North America?
Yeah, look, anytime I make an announcement of anything about the customer, I come from the school of thought, you need to get the approval from the customer. This is what we're going to say. Here is how it's going to be. And we do that. We will continue to work with our customers to see how much more we can communicate about who they are and what they are. I think it's important. But like I said, we're a little bit new into this space, and the other people they're working with, they spend a lot of money, and they don't, want us to, kind of be in a defensive position where they have to tell their suppliers who are you working with and why. But I do think that as we make progress, we'll be able to say more. Please be patient with me, and we will get there.
All right, this is the last pre-submitted question. Then we're going to roll on to some of the live questions from the chat. Can the yields for the HVM line be worked on, that's in air quotes, at the same time the team is producing batteries to be sold to customers? Or is yield work something that must be done as a separate sort of testing activity like FAT or SAT?
Okay, so the yield is an integral part of our FAT, SAT acceptance, right? So we don't accept machines till they come to the certain yield that we want them zone by zone. And SAT, we don't accept machines till the entire battery is producing at a certain level. And that's when we pay our vendors. Now, we'll continue to work on the yields after that to make them even better, and even higher. Because our FAT, SAT criteria, while they're high, there's more opportunity to continue to improve them. So yield is something that's consistently and continually worked on in all manufacturing companies. Again, we not only work on yield, we work on throughput, we work on how many units are coming out, we work on uptime of the machine, we work on what is called a OEE, which is the total output that comes out of that. So absolutely, we will continue to work on them.
All right, we're gonna go and roll over to some live questions. We've got a lot of people on, over 1,000, over 1,100 people watching right now. So let's take some questions from that group. First one, what internal testing remains on the EX1M battery samples produced before they are ready to be shipped to prospective customers? And how long will these internal tests take?
Yeah, so we're working on various different tests. One of the tests we're working on is kind of like, for example, external short circuit test. So you take a battery, you show the two terminals, and you see if the battery runs away into thermal runaway. We work on tumble test. We take the battery, drop it, and so on. We work on something called crush test. We take a battery and crush it and make sure it doesn't blow up. We work on something called an impact test. We take the battery, we take a big heavy iron bar and drop it on it and make sure it's okay. We work on fast charging. How fast is the battery charging? We work on things like cycle life. How many cycles is it going? And again, all these tests are tests we had in Inovix before. But what has happened since I've come on board is, since I have a very good relationship with all the smartphone OEMs, we were able to get from them the exact test they would do after we gave them the cell. And I asked them, can you please give me those tests so I can test them to that metric before I give it to you, so that the qualification will be much easier. So that's what we are working on. We have tests from various cell phone makers. Actually, interestingly, they're just a little bit different, by the way, based on their experience of how they felt their phones were used. And, that's kind of, we're in the middle of that. It'll take us a few more months to finish everything, but we will. But some tests, when they're completed, if they satisfy the OEM's requirements, we'll send it to them. Some tests, if they take longer for the other kind of OEM, that may take a little longer, right?
Okay, next question from the live stream is, will that top 5 smartphone OEM, which just had an agreement with Inovix, have any privilege over the next ones that will also sign with Inovix?
Yeah, I can't really comment on exactly what is in there, but I can tell you this much. There's a lot of interest from other OEMs too, and I'm hoping that we will sign more than one agreement. I mean, I can say this, the sooner these agreements are formalized, the more their engineering teams are working with us, the closer we're working. So I would say ability to launch sooner, earlier into the market is higher when you work closely with us sooner. So that's probably the way it goes.
Okay, next question. What does a JDA look like? Or pardon me, let me try that again. What does a JDA like the one last week entail exactly?
Yeah, agreements come in different forms. In fact, this agreement, without commenting specifically on this, I will say the kind of things that we typically look at is, number one, as I mentioned, the testing requirements. How do they test it? So they give us this document. It's very proprietary to them, and now we have that with us, so we know how to test it. They give us the exact shape and the dimensions of the battery. I think that is something we can build batteries to. They tell us which is more important, fast charge versus safety versus energy density, and what are the trade-offs we can make. Quality requirements, auditing of the factory, which phone model will it potentially fit into, and how does that look like? So this is like a joint, tight collaboration. My engineering team talk to customers' engineering teams every week now, sometimes more than once a week, to get these things ironed out and get closely. So they're committing resources, they're giving us information, they're looking exactly where in their portfolio our technology would fit. Those are all documented in the JDA.
All right, next live stream question. Given how important it is for smartphone OEMs to get your battery in their models, is there any chance they could reduce the acceptance time to 6 months rather than, say, 9 to 12 months?
It's possible. I mean, it depends upon how well our testing goes, and if our testing is almost identical to their testing and they feel it looks good, it's possible. But I tell you this much, though, people take battery testing very seriously because batteries are, very important, and they need to be safe, and they need to be tested for many, many cycles. So it takes more time, but it's possible, I'd say. But really, I think what we are most focused on is to make sure that the batteries meet the customer requirements, so when the phones come out, everyone is happy with it.
Okay, next question from the stream. Why can't other consumer technology companies replicate your technology? Seemingly, by the time you launch your EX2 platform, customers will have had time to increase their own energy density. That's a question.
Okay, so firstly, our customers work with other battery suppliers to get the energy density increase. They don't increase energy density themselves. If the question is about competition, you got to look back at the time, that the battery, silicon, lithium-ion batteries have been in the market. Over the past few decades, you can see the advancements have been very little, just a few percentage points, if you will, in terms of energy density. In terms of capacity, it's been more because the batteries kept getting bigger. And our technology of the way we manufacture the batteries, with the way we dice the electrodes and way we put constraints, is really the only technology I know that enables you to harness the power of silicon and get that higher energy density. So, we haven't seen it, and I think it's going to take time for anybody to make it. And I feel pretty confident with our roadmap that, when we start producing these batteries with 1M and 2M, they'll be leadership products.
Okay, next question submitted by a live viewer. Raj, if I've understood correctly, the qualification process is two-step, and it takes up to a year from first sample to PO. Is that correct? And how many rounds of samples are typically required?
Yeah, I mentioned 9 to 12 months for the customer to go to production from the time we give the first samples. The PO could come a few months before production, right? That's kind of the timeline I've mentioned. I would say typically, we give them samples with the current battery that we have. Then we give them samples, the dimensions exact of what they want. And that's probably the one that will go to production. So I would say 2. But if there's some changes they want in the middle, maybe there's a third one. But really, the time reduces. The time, I would say, starts from the first time we gave them some cells, right? That's how we should think about it.
Okay. On to the next question. Smartphone OEMs do not like to be single-sourced. How do you plan to address this issue with the kind of disruptive technology Enovix has to offer? Would you consider licensing technology?
Yeah, this is another good question. Yes, in general, OEMs who launch a lot of volume don't like to be single source, but I wouldn't say it's not possible. I think when I was at Qualcomm and TI, we were single sourced because there's only one place you can buy a Snapdragon processor or a TI OMAP. When I was at Micron, the memory is usually dual source or triple sourced, although sometimes we have gotten some single source opportunities. It depends on the technology, it depends on the timing, it depends on the volume. But if the technology is differentiated enough and you're the only one place that they could get it from, and they are comfortable with the advantages it's giving them, customers don't mind single sourcing, but you just kind of have to make sure you're really differentiated. Licensing, I mean, look, this is a business. If the licensing terms are good, we'll be open to it, but it's probably a little bit farther down the road.
All right, and this next question comes in. Could you please talk about the previous C-suite and the importance of the founders to the company?
Yeah, I mean, I think the founders of this company did a phenomenal job in building the technology. I mean, they've been here for 16 years. If you look at, Murali, Ashok, Harold, Cam, I mean, it's just a tremendous amount of commitment and a lot of hardship that they had to go through, up and downs to get to this stage. I think it's great work that they did. And built a lot of core technology, fundamental technology, a lot of patents in the company. I think it's really important. But I also think that the company is at the next stage where we need to productize the technology and get it to high volume production. And myself and the team that's here now have a lot of experience doing it. So it's a nice transition from developing of the technology and the innovation and the breakthrough that the founders did to someone like me and my team now will take it to the next level. So it's a great transition.
Okay, this next one submitted is a two-parter. Hey Raj, can you give us some thoughts on your vision for Inovix? In particular, where you think production could possibly be in 2 to 3 years? And part two is also, could you comment on the number of lines you would like to see Inovix running at this time? And whether you think it would be reasonable to see customers run their own lines in a partnership deal.
Yeah, great question. I mean, we spend a lot of time thinking about that. What's the future look like, and what's the vision of the company? And if you look at where we are, we're now able to make samples of the technology that meets customer requirements, particularly in smartphones and a lot of IoT devices. We now have a factory in Malaysia that can produce let's say 9 to 10 million batteries a year off of our lines. We now have an agility line that can produce different size of batteries and so on. We have space in the Malaysia plant to actually go up to 4 lines, and we have facilitated the site for that in terms of electricity, water, space, and all that. So that's really good. And hopefully in the next 2 to 3 years, we could start using all that space. But if the traction is really good and the customers love our product and they want to go much faster, there is some space nearby in that factory that we could expand into. We are getting interest from other countries asking us to see if they'd put the next factory there. And batteries is a lot of people realize what they want in different parts of the world. Is the demand being so much? So we discussed that. We've had conversations with customers talking about, hey, can we get our own line so that they get a surety of supply? I think all those conversations are happening. Just stay tuned as we make progress on the first battery and the first product and get into production.
Okay, and just a quick note to viewers, we are going to go for about another 12 minutes. We're going to do a hard stop at 6 p.m. Eastern. So if you've been watching, hang in. There's only a little bit longer and some good questions to come. All right, the next question submitted on the live stream. Does the number of cycles capacity correlate simply to lifespan of the battery, or are there other factors affecting useful lifespan? Will the Inovix cell phone battery allow phones to be kept in service longer?
Yeah. The number of cycles of capacity is basically the way we measure that is you fully charge the battery, you discharge the battery, you charge the battery, you discharge the battery. How many times can you do that before the battery doesn't perform the way it's supposed to, right? Most of you who have cell phones probably know that if you charge the battery and discharge the battery, when you bought your phone, it probably worked great. But as you used for a year or two, you'll see that it doesn't seem to last as long, which is kind of a well-kept secret in the, I guess, in the consumer electronic industry. What is happening at those stages is that now the battery is losing, as the cycles go by, how much of capacity it can actually hold, because of what's happening to the electrolyte, what's happening to the anode, what's happening to the cathode. So typically what happens is people will change the way the battery is getting charged, change the voltage and so on. So now it doesn't have as much energy. So it may go for more cycles, but it's not performing the way it did before, and then finally you change your battery. So that is what this relates to, cycle capacity. And what we are trying to do is to make sure that the batteries we give last those cycles and have a high capacity so that you don't have to charge them as many times. So if you get a battery with a higher capacity, you don't have to charge 2 times a day. You only charge once, which means that your battery will go longer. So the cycle, so the lifetime for how long you can keep the device is longer. But if your battery is going down, if you don't have as much energy density, you have to charge it multiple times, so it goes for less number of times. So they are related.
Okay, and just a quick note too, I'm seeing some repeat questions coming in that we have already answered earlier in the hour, and I just want to remind everyone that's viewing that maybe joined us late that this will be recorded and it will be accessible on our YouTube channel at this link after the conclusion of our stream. So we've got about 10 minutes left in our stream. Let's take the next question submitted. All the investors shorting Inovix ENVX must have some serious concerns about risks. Can you please address what they are concerned about, and do you think those concerns are valid?
I don't really know what people short Inovix on. I know there's a huge amount of short interest on the stock. I think some of it is personally. I think some of it is because of we came to be public company through a SPAC. And very few companies have been successful. I think some of these are probably algorithmic shorts where they just short, a bunch of SPAC-based companies. And the other thing is, we've had some missteps. We haven't been able to, it took a little longer. And factory in Fremont didn't really produce the batteries that it was supposed to, and various reasons for that. And I talked about in the past. So people felt that this battery is not manufacturable. I personally feel that those concerns are not so valid now with some data that, we've got this, our lines running now, the FAT is complete and the machines are coming in and we're making samples that the customers like. So, I feel pretty good, but, I don't know what those people who short them think.
Okay, it looks like we are, just want to double check here. I think we're going to take one more question and then we're going to call it. Comes in, thank you for doing this. I feel more supported as an investor and a fan of Inovix. What would be a home run for Inovix in your mind? What's your personal point of where success is for you?
Yeah, I mean, a home run for Inovix is to be a supplier of high performance, great lithium-ion batteries into consumer electronics and into EVs, whether they're directly or through some licensing and so on. Personally, success for me, if I look back at my career of past 30 years, I worked on the very first, or one of the very few digital cameras when the whole world was film. And every time I see somebody use a digital camera, it gives me great pleasure. I worked on MP3 players. I worked on DVD players. I worked on some of the very early cell phone cameras, and now you can see how big they got. I worked on memory and storage, and you can see how big those got. Worked on a lot of IoT devices. For me, I'd like to work and lead teams that'll change end user experience in a positive way. Right? That's where I get most of my excitement on working. And I think at Enovix we have that. If we're able to, and when we're able to produce this battery at scale, imagine a world where all your cell phones go much longer, all your consumer electronics devices go much longer, and you don't have to carry big batteries around. And it's a much greener world because you don't have to charge your batteries as many times. So that's kind of where I look at.
Well, that's all the questions, Raj. I'm going to go ahead and kick it over to you to just sort of close this stream out.
Yeah, guys, I got to tell you, thank you so much for your interest and for all the great questions. And we're working really hard. We have a great team, and we're making solid progress. And we'll continue to do this, whenever we need to communicate what we're doing and how it's going. On that, thank you for your interest. It's been my great pleasure and honor.